All right, we're going to do one more quick thing with the GCD. So remember in our previous theorem, we had this alternate way to think about the GCD. We said if we have two natural numbers, a and b, that the smallest positive linear combination of them is the GCD. And so the question is, how do we find that linear combination? How do we find the x and the y so that we can write the GCD as xa plus yb? So we're going to do this through an example. It turns out that the Euclidean algorithm, if we sort of use it backwards, is going to tell us that x and that y that we need. So our example is going to be 48 and 30. So the GCD of these, the biggest common divisor of the two of them is 6. 6 divides 48, 6 divides 30, and that's the greatest thing that does. Just as a side note, remember our corollary said any other common divisor has to divide the greatest common divisor? This is a good time to think about that. So, like for example, 2 divides 48 and 30, and notice 2 divides 6. 3 is the other one that divides both 48 and 30, but 3 also divides 6. So any common divisor of those two numbers is going to also have to divide 6. That was the little corollary to our theorem last time. All right, so let's talk about this GCD. We know the GCD is 6, and I want to find x and y so that 6 is x times 48 plus y times 30. Okay, so I want to be able to figure out what that x and that y are. And staring at that equation might work for you. You might find the x and the y, but what if it doesn't? How can we find them? So it turns out the Euclidean algorithm is going to help us with this. For homework, I had you read through the Euclidean algorithm for these two numbers. It was sort of written as a paragraph after an exercise in the textbook. And this is what it looks like if we write it down just in equation form. So we were going to take 48 and write it as 30 times something plus a remainder. So we're going to do 30 times 1 and a remainder of 18. And then the next step of the Euclidean algorithm says take that 30 and that 18 and do it over again. So use 30 is 18 times some quotient plus some remainder. So this time it's again 1 times 18 and under is going to be 12. And then we sort of repeat. So let's use 18 and 12 as our A and our B. So we have 18 is 12 times, again, 1 and a remainder of 6. And then we do it again, 12, 6. So we have 12 is 6 times 2 and a remainder of 0. And when we get to that 0 remainder, we know that the GCD is the one up above. So our GCD is this 6. Okay, so now we're going to use those same equations to try to find this x and this y. And this is kind of a weird process, but what we're going to do is start with that 6 equation. So I'm going to maybe number these. 1, 2, 3, 4. Okay, so I'm going to start with, whoops. I'm going to start with number 3 here that says 6 is 18 minus 12 times 1. Okay, and then I'm going to try to replace the 18 and the 12. So if I look at number 2 here, if I use number 2 replacement, I have 6 is 18 minus 12 can now be written as 30 minus 18 times 1. And so I've just replaced my 12 here using equation 2 with 30 minus 18. Okay, and now I'm going to replace that 18 in the same way using equation 1. So I can now replace my 18 with, let's see, what's equation 1? With 48 minus 30. Okay, and then I have another minus 30, and I have a plus 18, and 18 was 48 minus 30. Okay, so now I've replaced all of my numbers with 48s and 30s, and so what I get is that 6 is, let's see, there's a 48 and another 48, so I have two 48s, and then I have a minus 30, a minus 30, a minus 30, so plus a negative 3 30s. So that's my x2, and my y is negative 3. So I've found that linear combination, and just by kind of using these Euclidean algorithm steps sort of in reverse by replacing small numbers with larger numbers from the above equation until I get to the only 48s and 30s. Just one sort of interesting side note here. If you have ever seen these brain teasers about, like, you have a 5-gallon bucket and a 2-gallon bucket, and you need to somehow measure out 1 gallon of water. How do you do that? That's actually what this is doing for us. So it turns out the only times that you can do that are if the number that you're being asked to measure is the GCD of the two numbers, or a multiple of the GCD. And so the one that we just did is talking about, say we have a 48-gallon bucket and a 30-gallon bucket. Maybe I should talk about cups instead of gallons. So a 48-cup bucket and a 30-cup bucket, how would we measure out 6 cups? And this little equation tells us that. It tells us you're going to need to fill the 48 bucket twice, and you're going to need to dump out the 30 bucket 3 times. And so the way we would do it is fill up the 48, dump it to fill the 30. So now you've got 30 in one that's all the way filled and 18 in the other one. Dump out that 30. So now we're losing a 30. And then put the 18 into the 30. So now there's like 12 empty cups in the 30 bucket. Fill up the 48 again. Dump off 12 into that 30. Empty the 30. And now what's left in the 48 is 36. So dump off 30 into the 30 bucket, drain off the 30 bucket, and you've got 6 left in the 48. And so that was using the 48 bucket, filling it twice, and dumping out the 30 3 times, left us with exactly the 6 that we were trying to get. One way you can come up with these little brain teasers if you want to.